Hi guys, greetings of the day. Myself Vijit Vardhan. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 27, which is based on flow control valves. The function of flow control valve is to control the speed of hydraulic actuators, that is nothing but cylinders and the motors, by controlling the discharge Q. This is carried out by varying the cross section of an opening restrictor and thus varying the discharge or flow rate through the actuator. Then, the principle of speed control is based on a cylinder's speed is influenced by its bore size and the hydraulic motor's speed by its volumetric displacement Vd and the discharge or flow rate of the pressure oil into or out of the cylinder during the extension. The linear speed and the flow rate is related by the formula V is equal to Q by AP, where V is the speed of the cylinder in meter per second, Q is the flow rate of oil into or out of the cylinder in meter cube per second, and AP is the area of the cross section of the cylinder bore or piston in meter square. Similarly, the angular velocity of the motor and the flow rate is related by the formula N is equal to Q by Vd, where capital N is the RPM of the motor, Q is the flow rate of the oil into motor meter cube per minute, and Vd is nothing but volumetric displacement of the motor represented by meter cube per revolutions. Similarly, RPM of hydromotor is related by the formula N is equal to QTH by Vd, where capital N is the RPM of the motor again, then QTH is a theoretical discharge in terms of meter cube per minute, and Vd is the theoretical displacement of the motor in meter cube per revolutions. It can be observed that from these formulas that the constant speed can be achieved by constant flow rate for a given actuator. A large diameter cylinder would hold more oil and take longer time to complete its stroke, and the small one would move faster. Changing the flow rate of the pump would also change the extension and retraction time of the cylinder. Changing either the cylinder or pump to control speed would be impractical, especially when the speed change is desired in the middle of the stroke. The best solution to this is to control the discharge or flow rate using the flow control valve. By varying the amount of opening of the valve, it is possible to vary the amount of oil entering the actuator or motor and thus controlling the speed. A simple example of a flow control valve is considered as water tap. The excess flow is sent to the tank through the pressure relief valve. Depending on the accuracy which can be achieved, we can differentiate between a throttle and the flow control valves, and this figure shows the graphic symbols for different restrictions of passage like non-variable or fixed restrictions and variable restriction, throttle with reverse free flow and two-way control valve and three-way flow control valve and the flow divider, etc. Then, what are the factors influencing the flow rate of a fluid or the orifice size or opening? The flow or velocity V of the fluids depends on the flow rate Q and the area of cross section capital A of the flow, and mathematically expressed as capital V is equal to capital Q by A. It can be observed from this relation that the velocity of the flow is inversely proportional to the area of cross section of flow for a given flow rate. As area of cross section decreases, the velocity of flow increases and vice versa. This is one of the methods adopted for controlling the speed of actuators. By varying the orifice size or opening, the flow velocity of the oil can be varied, and this is the principle of flow control valve. Then coming to another parameter, pressure of fluid. The square of discharge Q square of a fluid through an orifice or an opening is directly proportional to the pressure drop across the orifice. Once the discharge or flow rate increases, the velocity of flow increases. That is, Q square is directly proportional to delta P. That is, flow rate is directly proportional to change in pressure. And we also know that V is also given by Q by A. Hence, this equation can be re-altered as V square A square is directly proportional to change in pressure. If the speed of an actuator is to be maintained constant using a flow control valve, one should be careful to see that the pressure drop across the valve is zero. This is to be separately carried out in the valve. Otherwise, in conventional flow valves, there will be drop in pressure, hence the discharge, and finally the flow. Hence, it is not possible to maintain constant speed of an actuator using conventional flow valve. Such valves are called as non-compensated flow valve. And the another parameter is called as fluid temperature. The viscosity of liquid varies with temperature and inversely proportional to the temperature. That is, as the temperature increases, viscosity of the fluid decreases and the fluid becomes thin and flow easily. Similarly, as the temperature decreases, viscosity of the fluid increases and the fluid becomes thick and flow becomes difficult. That is, the temperature influences viscosity and viscosity in turn influences velocity of flow. Temperature of a flowing fluid increases due to external resistance to flow, sudden expansion and contraction in passage, sudden change in direction, environment, and so on, which in turn influence the velocity of the actuator. If a conventional flow control valve is used to control the speed of an actuator, there is no compensation for change in temperature, and such valves are also called as non-compensated flow valves. Now, let us understand the classification of flow control valves. Flow control valves are broadly classified into two types. They are non-compensated flow control valve and compensated flow control valve. In non-compensated flow control valves, these valves, flow control valves, does not compensate for the variation of flow rate due to either pressure or temperature. As pressure varies, flow rate also varies. Similarly, as temperature of fluid varies, its viscosity varies, which affects the flow rate. Non-compensated flow control valves are those valves in which the flow rate varies due to variation in pressure and temperature for a given orifice opening. The flow control valve in these valves are simple variable orifice, and the different types of non-compensating flow control valves are sliding spool valve, needle valve, globe valve, and gate valve. Then coming to the another classification, that is compensated flow control valve, which is having a subclassification like pressure compensated flow control valve. Either it could be a bypass type or restrictor type. Now let us discuss in detail about a non-compensated flow control valve one by one. Now let us discuss sliding spool valve. Sliding spool valve, as the name indicates, it has a sliding spool inside a cylindrical jacket which on sliding controls the flow by blocking the opening partially or completely. This often combines the flow and direction control and functions also as a direction control valve. The spool is located centrally in a bore. The land blocks the flow through the passage alternatively and permits selected flow of fluid as the spool moves within the bore, and figure shows the basic principle of sliding spool valve, which is on the left hand side in the slide. Coming to the next type of valve is called as needle valve. Needle valve is the most commonly used hydraulic flow control valve. This consists of a needle or a pointed stem that can be adjusted manually to control the discharge. These valves are often made out of steel and are also used as stop valve to prevent the flow of fluid from one part in the hydraulic circuit to the another part, which you can see on the right hand side of the slide. Then coming to a next type of valve that is called as a globe valve. This is also a basic two-way valve. This consists of a circular disc at the end of a threaded stem. The threaded stem engages with the inner threaded portion of the body, which you can observe in this figure on the left hand side. The area for flow of fluid is much larger in this valve when compared to a needle valve, and hence the flow capacity is larger at a lower pressure drop and than a needle valve of the same size. Since the area of flow is not so gradually reducing as in case of a needle valve, this valve is not suitable for throttling purpose. Then coming to the gate valve, this has a large cylindrical body with a frustum of cone head, which serves as a gate between the inlet and the outlet of the valve. The gate is freely mounted to a threaded stem as shown in the figure on the right hand side of the slide. The threaded portion of the stem operates in the matching internal thread provided in the body of the valve. This in turn moves the gate up and down, opening and blocking the passage. Gate valves provides much larger opening than the needle and the globe valves, resulting in much larger flow capacity at a lower pressure drop. Gate valves are normally used as a flow control valve but are generally used as a shut-off fluid flow or to open the line to the full flow. So by thus, the time allotted for the session is expired. Henceforth, I'm going to stop the session over here. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan.